Example number 4. A car A is traveling west at 50 miles per hour and car B is traveling north at 60 miles per hour. Both are heading for the intersection of the two roads. At what rate are the cars approaching each other when car A is 0.3 mile and car B is 0.4 mile from the intersection? So let's draw the picture for this. So we have north, south, east, and west, right? So for the car A is travel west. So car A go this direction. So let's call this is car A. And then car B travel north direction. So this is car B. So we see the picture and we can see that there is a distance between car A and car B, and we call that is the z distance. And then the question asks us to find the change of the distance between car A and car B with respect to the time. So that is the dz divided by dt. So this is what we're looking for. The reason why is that because if car A move a little bit, for example to this point, and then car B move a little bit to this point, then the z will be different. So the z changing when the time change. And we interesting to know what is the change of z with respect to t. So let's assume that we have car A travel 50 miles per hour and car B travel 60 miles per hour, and assume that we have car A is 0.3 mile away from the intersection. So this point is intersection, so let's call this is the point C. So the car A is about 3 miles, so 3 miles from the intersection, and car B is 0.4 mile from the intersection. So we have the z is right here. So let's call this is x, and let's call this is a y. So we have the relationship between x, y, and z. So we have z equal z squared equal x squared plus y squared. We use Pythagorean theorem, right? And now we want to find the change of z with respect to t. So what should we do is we will take the derivative with respect to t for both sides for this equation. So we will get 2z dz dt, and then 2x dx dt plus 2y dy dt. Now we can cancel out the 2, so we will get z dz dt equal x dx dt plus y dy dt. We already know x is 0.3, we know y is 0.4, and the rate is the change of the x is the rate of car A, which is 50. So this is dx dt, and this is dy dt. Both of them will be negative, and you know why? Because the direction we choose is A travel negative direction and B also travel negative direction. The problem is we don't have z yet, so we use the Pythagorean theorem again, go back, and then we will plug in for x and y. So x is 0.3 square and y is 0.4 square. So z equals 0.09 plus 0.16, and then z equals 0.25, z squared equals 0.25. We interesting to take positive because z is the distance, so 0.5. Then we have 0.5. Then you solve for this equation, and you will get negative 78 miles per hour.